Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 1799 that says maximize score after an operation. So guys, solving this question you will learn a new concept of using bit masking for memorization purposes. So yeah guys, stick till the end, watch the complete video and make sure to like and subscribe to our channel. So here you are given one nums array and an array that is of size 2 into n, where n is the number of operations you can perform. Okay, so let's say if you can perform n operation, then the nums array size would be 2 into n. Further, what is the ith operation? In the ith operation, we choose two elements x and y. Then we try to calculate the score. Score is nothing but I into GCD of x and y, and then we remove x and y from the nums, and then again calculate the score of other elements, right? So yeah, by doing this, we need to return the maximum score after performing n operations, and this GCD is nothing but the greatest common divisor of x and y, right? So the question is pretty much straightforward, that we need to choose some elements x and y wisely. That way it return the maximum score at the end, right? Everything depends on choosing the characters x and y. Okay, right? Now if you take a look at the test cases or the examples, so here there is only one option to choose x and y. This element is x and this is y, or this is x and this is y. So yeah, this is the straightforward here, because we have only one pair of elements for x and y. So here we find 1 into, because this is the first operation, so 1, and GCD of 1 and 2, so answer is 1. Now guys, if you look at this example, to get the optimal answer we have to choose these two pairs. So let me show you. So we have to choose 3, 6 in one pair, and the other pair we will choose 4 and 8, right? In the first operation we will choose this, and second operation we will choose this. So first operation is 1 into GCD of 3 and 6, second operation is 2 into GCD of 3 and 4 and 8, so it is 3 plus 8, so overall answer is 11. This is the maximum answer you can get. So now what if you had did 1 into GCD of 3 and 4, if you did like this, plus 2 into GCD, this is GCD of 6 and 8, if you did like this, what would be the answer? See, now 1 into GCD of 3 and 4, what is the greatest common divisor of 3 and 4? It is nothing but 1. Plus 2 into GCD of 6 and 8, what is the greatest number that divide both 6 and 8? It is 2. So this is 1 plus 4, so this is 5. So this way you will get answer 5. But if you perform in this way, if you choose 3 and 6 and 4 and 8, you will get the best possible answer, that is 11. So guys, the whole question lies in choosing x and y efficiently. That's how we will get the maximum answer. Got it? Now similarly in the third example, if we will choose 1 and 5 here, then we will choose this 2 and this 4, then 3 and 6, this is 3 and this is 6 here, and yeah, this is the first, this is the second, and this is the third operation. We sum them, we sum all this and get the answer 14, and this is the best possible answer here. Okay, so guys, the complete problem revolves around choosing the two elements. If we choose two elements wisely, then we will get the maximum answer. And yeah, in each ith operation we are performing this, choosing two of elements, calculate the score, remove x and y. So remove x and y from now, that means this is nothing but calculate remaining score. This is nothing but to calculate remaining score. Okay, now since we have choices, we can think of recursion. Okay, yeah, we can think of recursion. So if you would perform recursion, then it would be something like this. So for an example, if you have some elements a, b, c, d, e and f, so first let's say we took a and b in the first step, so we get this state, c, d, e, f are remaining. See, we get a and we choose a and b and we calculate some answer. Now the other answer or the remaining portion will define our answer, total answer, right? So yeah, we have to check what elements are that we picked and what are the remaining elements. We have to keep track of this, right? Then only we can take care. This is the set of elements that is remaining, and we have to pick from them. So we have to make sure what the elements are already picked and what are remaining. So we have to keep track of that. So let's say we choose a and b. This is the remaining. A and c. We can choose a and d, a and e, a and f. So likewise we can choose b and c up till e and f, right? So there are many choices here. Okay, and each choice will result in some other remaining set, right? This a, if you choose a and b, remaining is c, d, e, f. A and c, the remaining is b, d, e and f, right? So yeah, this way the recursion will work. But at some point, let's say from this state, if you choose b and d, the remaining state is e and f. If you choose B and C, the remaining state is E and F. Now you will see that there will be repeated state. So this state is repeated 2 times. Now is it efficient to calculate the answer for E and F each time? No, it is not efficient. So since there is a repeating sub problems, right? We choose one set, there is a remaining set. We choose one set, there is a remaining set. So this remaining set of elements is repeated. That means it is nothing but repeated sub problems. And guys, as you know that whenever we have repeating sub problems in the recursion, what we do is we choose memoization. That means we will calculate only once for this E and F, and then we will directly use the answer that is already calculated, right? We won't calculate for this repeating sub problems like E and F for each time. We will calculate once, store it in our dynamic DP array, and use that answer everywhere. Okay, got it? So yeah, this is how recursion will end up in creating repeated sub problems, and then we have to introduce memoization. Now for the memoization part, 2 things we have to consider. First is keep track of remaining elements, right, and store the answer. This is nothing but DP array. So first we can think of how we can keep track of the remaining elements. Let's say we choose A and B, then we need to keep track what are the remaining elements. Okay, so for that, considering that we can either use a boolean array. So let's say boolean array, if you are given n1 up till n6, that is 6 elements, we can create what boolean array, that will store true, false, false, true, false, false. So here this boolean array, something like this, it will represent that 2 elements are chosen, 4 elements are false, that are not chosen, right? So something like this we can keep track of boolean array that will operate in big of 1 time complexity, because we can choose an element and make let's say make visited of n4 equals to true. That means we have marked the n4 element as chosen, so that this operation is nothing but takes big of 1 time, but this array will take big O of n space complexity, right? Because since this is an array, so yeah, and we need to keep track of all n elements, so yeah, it will take big O of n space complexity. Now what is one another way we can do this thing? Can we use mask? Okay, so if you would use mask, then it will take big O of 1 time as well as big O of 1 space complexity. Now many of you might have a question of what is mask. Let's say if you want to represent an element phi in binary, then what is it? It is 1 0 1, that is 4 plus 1, this is 5. Okay, so this is a binary representation of phi. Now let's say you are given one array. Let's say you are given one array of size, let's say size 6, size equal to 6. So initially what is the mask? All elements are not chosen, so let's say this is the mask. Okay, so this is nothing but 0. Now let's say at some time t equal to at some point t, okay, just assume at some point t you will choose element with index 1 and you will choose element with index 3. You will choose one element with index 1 and index 3. So yeah, here what we will do is we will mark that index as 1. So starting from the right, 0 1 2 3 0 0. See, this is what the binary of all zeros is nothing but 0 and decimal. Now binary of this is 1 0 1 0. What is this? It is 2 plus 8. This is 12, right? Now let's say at some point t dash, you can say you will choose all element, right? At some point all the elements will be chosen. So what is this representation in decimal? It is nothing but 2 to the power 6, because there are 6 elements. So by masking, what we can do is we can take one integer. So what integer we will take? We will take some huge integer, let's say 2 to the power 6. For here we took 2 to the power 6. Okay, now from here 2 to the power 6, how many elements we can keep track? 1 2 3 4 5 6. 6 elements we can track by changing their bits. There are 6 elements we can track, right? We just need to track whether the element is selected or not, whether the value is true or false. So if you took a decimal number 2 to the power 6, in that you can keep track of 6 elements. So yeah guys, here we just need to keep track whether the ith index is 0 or 1. So for all the 6 elements we can keep track, right? Either the number is 0 or the bit is 0 or 1, right? For all these 6 elements we can keep track whether the number is chosen or not, taken or not. So guys, that's why we can use mask here. Now but another thing, see, what is the maximum number of bits present in the mask? It can be 32. For an integer, maximum number of bits is 32 for an integer. So we can store 32 different numbers that are chosen or not, 32 different indices of number, right? From 0 to 0 index up till 31 index, we can store in an integer size of bit, integer size of mask. Okay, because we have 32 bits here for an integer, so we can choose this state whether the element is chosen or not for 32 different elements, that is from index 0 to 31, right? So that's why we can say we have 32 options for 0 and 1 in an integer, or true and false, 0 and 1 or true and false, we can say. Now here the given m, or the size of the nums array, is less than equal to 14. If you guys check the constraint, the n is 7, the total number of operation, and the nums length is 2 times of 7, that is 14. So guys, this 14 is less than equal to 32. It is less than equal to 32. That means here we can use mask, right? We can simply use mask and reduce the space to big O of 1. Instead of using the boolean array, we can reduce the space to big O of 1. Got it? If this size of the nums array, if let's say m is equal to, let's say, 18, so let's say n is 18, that means 18 operation, so nums size would be nothing but 18 twice of 18, that is 36. So in this case we won't be able to use integer size of mask, because we have 36 different possibilities and integer size of mask can only store 32 bits. So that is 32 different possibilities. So guys, in this case we won't be able to do this. But since here the maximum different possibilities or the size of the nums array is 14, so yeah, we can use mask to store this thing, whether the element is taken or not, whether it is true or false, right? So this is one thing, to keep track of remaining elements by keeping 0 and 1. Second thing we need to also do is store the answer for the DP array inside the DP array. Now what would be the size of the DP array, right? That's the question. See guys, let's say here if you have 14 times 1, right? Now what it would be the decimal representation of this 14 times 1? It is nothing but 2 to the power 14, right? So our DP array size would be nothing but 2 to the power 14. This would be the size of our DP array. So this would be the maximum size of DP, right? This would be the maximum size of DP array needed, right? And 2 to the power 14 is nothing of some value like 16,000. It would be somewhat greater than 16,000, this value. So we can easily store this many value in this DP array. That means we can easily create the DP array of size this, right? It is easy. This won't take much space. So yeah guys, by combining all these things, by using mask, by using the size of the DP array that we have calculated and understood, by using all these different concepts, let's move on to the coding part and see how we will solve it. Okay, so initially I took m, that is the size of the nums array. I generated the maximum mask value. What is the maximum value of the mask? That is nothing but 2 to the power m. So in the binary or by using bitwise operation, that is left shift, we can perform 2 to the power in this way, that is 1 left shift m times. We created this DP array of maximum mask value comma -1, that is store the -1 inside this DP array, and this call the solve function. Now inside this solve function we check for the base condition if the count of operation, see here we are taking mask count of operation, DP array as well as the nums array, mask count of operations and they both are changing variables. Now for an instance, if the count of operations greater than n, see how many operations you can perform, that is the nums dot size divided by 2, these many operations you can perform. And if the total count of operation is greater than equal to n, that means all the operations are now done. So in that case we would return 0, nothing is remaining. Now if there is an overlapping sub problems, that means a sub problem is already calculated and thus DP of mass is not equal to -1, then in that case directly return DP of mass or the store value inside this DP. Now then we took maximum score and these two for loops. Now inside this for loop we are taking the value of first number I and the second number j. Okay, we will check if the mask of I is already 1 or not. So for an example, let the current value of mask is this. Okay, let's assume the current value of the mask is this is the current mask. Okay, now let's say I is nothing but first index, so I is nothing but 1 here. Okay, now we have to check whether the nums of I or the first index is chosen or not. How we will do that? We have to check whether these elements, see this is 0th index, this is first, second and third, whether this element is 1 or not. We need to check. How we will do this? What we will do is we will do 0 1 1 0. We will right shift I number of times. That means if I is 1, we will right shift 1 time. So what would be the value of I is here, I equal to 1. So what would be the value of this right shift? It would be 0 0 1 1, right? 0 0 1 1. Then what we will do with this value, we will take bitwise AND with 1. That 1 is nothing but 0 0 0 1. We will take bitwise AND with this one, and by performing bitwise AND, if you will get 1, that means last bit, if it is 1, then that means the ith index or this bit is 1, right? We have shifted and moved to the last position, and we took bitwise AND with the last position. See, all would be 0 because it is bitwise. So this 1 and 0 is 0, 0 and 0 0, 0 and 0 it is 0, right? All would be 0. But since this is 1 and 1 bitwise AND with 1 is 1, so we will check that mask right shift of I number of times and then taking bitwise AND with 1 whether it gives a result 1 or not. If it gives a result 1, that means the number is already chosen, already selected, or you can say chosen, or you can say pick, already picked. Then in that case we would continue and don't process for that index sign. Got it? Right? This is how this right shift operation takes place, right? It shifts all the bits right towards the right I number of times, and then if this condition doesn't satisfy, then we will choose that I and we will try to select different j. Now we will start the loop for j from I plus 1 up till m, and we will also check for the j for the same condition if the nums of j is selected or not. If it is not selected, then what we will do, we will try to calculate new mask. So for, let's say, original mask is this, and let's say I is 3, and let's say I is 0 and j is 3. So this is 0 index, first index, second index, and third index. Now what we need to do is we need to mark these as 1 as well as this as 1 because we are selecting these two, I and j. So what we will do here is we would do 0 1 1 0 bitwise OR. This is bitwise OR with what? 1. This is nothing but left shift, 1 left shift I number of times. So I is 0, so we will take 1 here, this would be 0, and again take bitwise OR 1 left shift j number of times. So that means 1 0 0 0. So we will take bitwise OR of all these three numbers. This is 0, and our answer would be 1 1 1 1. See, this was the original mask. This is the new mask that we produce, where we select the 0th index as well as the 3rd index element. So guys, this is how the new mask is formed, where the ith index and jth index element is marked as chosen, right? They both are 1 now, so initially they both were 0. That means they were not picked. Now we are picking them and we are marking them as true. That means these two elements are chosen. So guys, this is how new mask is formed. Then we calculate the current score. Current score is nothing but count of operation plus 1 multiplying the GCD of nums of I and nums of j, and the remaining score is nothing but the recursion answer that we will get from recursion, that is solving for nums, the new mask, count of operation plus 1, and the DP array. And we will keep track of maximum score, that is nothing but maximum of maximum score and the current score plus remaining score. This is the current state, right? So we will take maximum of both of them and store in the maximum score, and at the end return DP of mask is equals to maximum score. So guys, I hope you have understood that how we are performing this bit masking, how we are performing this left shift, right shift, marking the element as chosen or not by shifting the bits and taking a mask of it. So yeah, this was all about this question. Now here we are performing GCD, right? But we can do one thing, we can optimize this thing by pre-computing. So in this approach, what I did is I pre-computed GCD of all I and j combination, right? Of all I and j combination, we pre-computed, and I directly used GCD of I and j instead of calling the built-in method GCD. I pre-computed and directly added GCD here, right? GCD of I and j, right? So this will save a bit of time complexity here, right? Instead of calculating GCD all times, I pre-computed and directly used GCD of I and j. Now guys, talking about the time and space complexity. So for this above approach, the time complexity here is, let's calculate. So how many different states are there? The different possible states are nothing but 2 to the power m, because where m is the size of this nums array, so this many different states. for each time we are iterating for m square, we are using m square, that means 2 inner for loops multiplied. Each time we are also calculating this GCD. This will take log of 10 to the power 6, right? Because this is the maximum element we have, so it will take big log of 10 to the power 6 maximum time. So this is the time complexity for this approach. Number of state, for each state we are calculating this, right? And the space complexity here is nothing but 2 to the power m, because that size of DP array we are using here, 2 to the power m. That means this is left where m is the size of the nums array. Now here, since we are pre-computing this, this will save a bit in our time complexity, and our new time complexity would be, see, it would be m square, because pre-computing will take big O of m square, plus how many different states, 2 to the power m into m square, because for each state we are again taking 2 inner for loops. So yeah, this is our new time complexity, and the space complexity would be 2 to the power m for this DP array. And what would be the size of this GCD? This GCD would be nothing but of a size m square. So this would be our new space complexity. So yeah guys, that's all for this video. If you guys have still any doubts, then do let me know in the comment section. Make sure you like the video and subscribe to our channel. Thank you.